see the screen, 9.3 constant acceleration Formula 1. Now, I know that some of you did ADMAS last year, so you've been introduced to SUVAT, but I'm just going to run through it as if you haven't. So, got to get used to these letters, S, U, V, A, and T. So, S is the displacement, so that's obviously the distance in a specific direction. U is the initial velocity, so that's the initial speed in a specific direction. V is the final velocity. A is the acceleration, and T is the time. So you obviously need to be familiar with those five. Now, we're going to be covering 5 SUVAT equations, and in this next bit that we're moving on to, it's going to be exercise 9C, it just focuses on the first 2 of the SUVAT equations, both of which, in theory, you could be asked to derive from first principles in an exam. Okay, so they both come from the velocity time graph. So here's our velocity time graph. As you know, the rate of change of velocity, so the slope of a velocity time graph is the acceleration. So how do we work out the acceleration of the gradient of a straight line? It's obviously y step over x step. So our y step is this length here, which is v take away u, and our x step is t. So our gradient of our line is v minus u over d, and as we said, the gradient is the acceleration. So there is our starting point, just rearranging that, so multiplying by t and adding u, we get our first of our SUVAT equations, v equals u plus at. So that comes from the gradient of the line, and secondly, as you know, the area under a velocity time graph is the displacement, the distance traveled. The area under is a trapezium. So how do you work out the area of a trapezium? You average the 2 parallel sides. So that length is u, and that length is v. There are 2 parallel sides. There's u, there's v. So we average those 2 parallel sides by adding them together and dividing by 2, and we multiply that by the distance the 2 parallel sides are apart, which is t. So our shaded area under the graph is displacement, so that equals the u plus v over 2 times t. So that is our second of our SUVAT equations. So as I've underlined here, you need to know how to derive these formulae from the velocity time graph. I think it would be a gift if that actually crops up in a test, but it's in the syllabus, but you never know, it might do. So there are then a number of examples where literally we're just plugging in the information. So they just give us the facts. You just make a list of what we've been told. U's for, V's this, T's this. And we're being asked to work out S and A. Choose the appropriate equation, sub in. And similar examples 5 and 6. So I was in 2 minds to say whether we should try and do more than just exercise 9C before Friday. But there are 13 questions here, and towards the end, they do get quite complicated or quite time consuming. So I think on balance, I'm just going to say, let's just get 9C done before the next time I see you, which is Friday. I think one of the things that swung it, initially I thought Friday was wasn't school, but it is school. I mean, I don't know if you've been informed of this yet, but it would have been the insets day, which is not happening. So it is, and certainly the morning, I'm not so sure about the afternoon, but the morning is definitely normal lessons. So bearing in mind that almost gives us an extra lesson I thought we might not be guessing. So we will move on to the second part of SUVAT on Friday, period 3, please. So it'd be great if you guys could work through exercise 9C and get that completed by Friday. As always, if there are any bits and bobs you can't do, just give me a quick post and I will get back to you with a video or a live call or something. Izzy, you're bang up to date with the assignments, so well done on that. James and Patrick, if you could still try and get that earlier mechanics assessment done, that would be assignment done, that would be great, please, that unit test, because it would be nice to keep nicely up to date. So thanks for joining me, guys. Have a good week. So 9C to be done by Friday, please.